Hey guys, welcome. So today let's look at this question chess tournament from Green Book. So it's a good question to understand some of the basic principle of counting in probability. So there are two ways to solve this question, but as always, I'm only going to show the approach which is easiest to understand. So the question states that a chess tournament has 2 to the power of n players with skills as 1, 2, and goes up to 2 to the power of n. It is organized as a knockout tournament so that after each round, only the winner proceeds to the next round. Okay, except for the final, opponents in each round are drawn at random. Okay, let's also assume that when two players meet in a game, the player with the better skills always wins. So let's say if player with skill 2 and 5 plays a game, then it is guaranteed that the player with skill 2 is going to win. What is the probability that player 1 and 2 will meet in the final? Okay, so let's look at this. Chess tournament. So first we'll see, as always, I try to, whenever I come across these questions where in the question it is given that there are n things, and like here it is stated there are 2 to the power n players. So I try to start with the base case with n is equal to 1, n is equal to 2, and so on and so forth. So here if we, let's say, start with n is equal to 1, then that means there are 2 players. And for 2 players, obviously player 1 and player 2 will play. So no matter who plays, since there are only 2 players, it is 100% ensured that 1 and 2 will play the final, because there will only be going to be one match. So for this case, we'll know that probability is equal to 1. Okay. Now let's take the case of n is equal to 2. So in case of n is equal to 2, there will be 4 players. Now, to have a tournament between 4 players, we will first have to divide these 4 players into 2 groups, right? Here we have group 1 and then group 2. So in group 1 there will be 2 players, and similarly in group 2 also there will be 2 players. And whoever wins, the winner of group 1 and winner of group 2 is going to play the final. Now we know that player number 1, so player number 1 has the highest skill. So no matter in which group he is, it is guaranteed that he is going to come on top. So whether he is on group 1 or group 2, or if there are, let's say, n groups and 2 to the power n players, no matter in which group he is going to come on top because he has the highest level of skill. What we want is that, imagine if there is one group, here group 1, in which both player 1 and player 2 are in the same group. That is, player 2 enters the same group in which player 1 is. So if that happens, then we know that out of each group there is going to come out only one player that is going to play with the finalist of another group. So since we know that from group 1 only one player is going to come out, and if player 2 is also along with player 1, then it is guaranteed that player 2 will get eliminated, which we do not want. Because in the question we want to find the probability that players 1 and 2 will meet in the final. So in a way, we are saying that we want a distribution of players in groups in such a way that player 2 does not belong in the same group as player 1. So all we have to do is find the probability that player 2 is not in the same group as player 1. So let's see how we can find that. So group 1 has 2 players, so there are 2 seats, and group 2 has 2 players. Now let's randomly put player 1 in any group, that doesn't matter. So let's say player 1 is in group 1. Now, how many options are there for player 2 to pick? So player 2 can either come here or here or here. So total there are 3 seats available for player 2. Now in which seats can player 2 go such that player 2 and player 1 are not in the same group? So as you can see, these are the 2 seats where this is the only seat where if player 2 goes, then player 1 and 2 will be in the same group. Otherwise, in these 2 seats, player 2 and player 1 will be in different groups. So there are two such seats. So our answer will be 2 by 3 when n is equal to 2. So from this n is equal to 2 case, you can generalize the case for 2 to the power n players. So for 2 to the power n players, again we will make two groups, group 1 and group 2. Now group 1 has 2 to the power n by 2 players, as we'll divide the 2 to the power n players in two equal groups. Here also we have 2 to the power n by 2 players. So let's assume that player 1 plays. So these many seats are there in group 1. So player 1 plays in group 1. And we have to ensure that the player 2 does not come in group 1. So in the denominator we will have the total number of seats which are available for player 2 to select. So there are total 2 to the power n seats, out of which 1 is already taken by player 1. So we have total 2 to the power n minus 1 seats. Now, how many of these seats are good seats? Good seats in meaning such that player 1 and player 2 doesn't appear in the same team. So all the seats on this side on group 2 are the good seats. And how many seats are there? 2 to the power n by 2. So our answer will become 2 to the power n minus 1 upon 2 to the power n minus 1. So this is the probability which is being asked in the question. So just by counting, we can see how easily we can formulate the problem, and we were able to solve it. There is another approach to solve this question, the standard approach of conditional probability, which is mentioned in the Green Book. And the second approach is also explained in the page below here. So I hope with this explanation you are able to grasp the concept clearly. If there is any query or doubt, please feel free to ask me in the comments. And that's it. I'll see you next time with another question.